have x squared, how that's written out long terms is it's x times x. That's what the 2 means, is you're taking the base twice. So how many times would you multiply x if it was x to the 4th? 4. So it's just multiplying that base number that many times. It's a shorthand way to write it. How would I write the following in exponents? A cubed times b squared. Now you notice I didn't put dots in between here. Even if there's not dots, if 2 variables are next to each other, it's assumed that they're being multiplied. Okay? So it's okay to write them without the dots. It's okay to write them with the dots. It's okay to write this as a cubed b squared. That's okay. Different ways to write it. Okay. Let's talk about the multiplication rule for exponents. Can you guys see this marker? It seems kind of dull. Okay. The multiplication rule says if you have one base with an exponent times another base with an exponent, you're going to keep that same base and add the exponents. So again, when you're multiplying exponents with the same base, you simply use the same base and add the exponents. For example, y cubed times y to the 6th becomes y 3 plus 6, or y 9. If I have 4 times 4 cubed, how do I multiply that? 4 to the 4th. 4 to the 4th. Very good. Did I hear a what? Oh. What if I wrote it x squared x to the 5th? Yeah, so it would be x 7. Do you notice I on purpose left out the dot here? Just because I want to show you there's different ways to do it. Okay. Tell me which one of these examples is right. I heard first and second. Raise your hand if you think it's the first one. Raise your hand if you think it's the second one. Okay. It is this one. Because when you're multiplying with exponents, you want to keep the same base. You do not multiply the bases. Okay? Nope. This equals 27. Oh. And this equals whatever 81 times 9 is. So they do change the answer. When multiplying, do not multiply the base. This marker is awful. Excellent. So that's your multiplication rule. The next rule is the quotient rule. What does quotient mean?
Multiplying powers of the same base do not multiply the base.
Oh, sorry. When multiplying powers of the same base, like taking the power of something, the exponent, do not multiply the base. The example I showed you right above it is what I'm trying to say. Okay, what's a quotient? Division. Good. So, the quotient rule works like this. If I have a base with an exponent, Instead of adding, I am subtracting those exponents. So multiplication of exponents is adding, division of exponents is subtracting.
Would you always subtract the numerator and exponent from the denominator?
Yes, always in that order, top minus bottom. Good question. And this is assuming that x can't be 0. Because what happens if you have 0 on the bottom? It's undefined, right? That's just assuming there's no 0 on the bottom. So let's look at an example.
But even if the exponent's 0, it'd be undefined, or no?
No, we'll talk about that in a minute. If the exponent's 0, it's going to be 1. X can't be 0. The number, the base itself can't be 0. If I wrote the division like this, I can still rewrite it this way, couldn't I? So it still means x to the 8th over x squared, which sometimes is an easier way to look at it when we're working with exponents. So if it's x8 divided by x squared, I'm simply going to subtract the exponents, and I get x to the 6th. Okay, look at another one. 2 to the 6th divided by 2 to the 4th. What should that be? 2 squared. Now in this one, I can finalize the problem because I have a real number here. What is the answer? 4. When it's a variable with an exponent, you can't do anything more. But when you have a number with the exponent, go ahead and write what it is. Don't leave it an exponent. Very good. Another example. What would this one be? Z to the 4th. Very good. What if I had...
Oh no.
What?
You change the numbers.
Yeah. What happens if I do that? You can't subtract exponents. They have to have the same base.
So it would just be 3.
Whatever this number is, which is 81, you would find what the answer is and then work it like a math problem, 81 divided by 16.
Okay.
But let's say it was x and y. X to the 4th, y to the 3rd. Can I do anything with that?
No.
No. You can only subtract or add exponents if they're the same base. I see some inquisitive looks. Yes, Scott?
What happens when you get into like negative exponents?
We're going to cover that in just a minute. Yep. For sure we will get to it. Okay, so do you understand you can only multiply or subtract exponents if they have the same base? That's important. Very good. See, I knew this was going to be easy because you guys are hurrying me to do the harder stuff. X4 divided by x4th. What should that be?
1.
It's 1. But look at the math of it. If I said 4 minus 4, it's 0, right? Therefore, it's 1. So anything raised to the 0 power is 1. And that's just an example to show you why. So anything with a 0 exponent is 1.
No matter what x is.
Whatever x is, except, there's one exception, x cannot be 0. So you can't have 0 to the 0 being 1. That is undefined. So anything except 0 raised to 0 is 1. But 0 to the 0 is undefined. Okay, anything else is 1. So what if I have this problem? How could I solve it? It's 8 times what? Yeah, 8 times 1, which is just 8. How about this problem?
4, so it's 2.
It's -2. So it's -2 times this whole thing goes to 1. Because the whole parentheses is to the 0 power. So it's 1. Therefore, the answer is just -2. All right. Any questions on that, the 0 power? The next rule we need to learn is called the power rule.
Why is it 1?
Why is it 1? Where? Here?
Yeah, no. Down there.
Here?
Or X.
Okay, because whatever's in this parentheses is being raised to a 0 power. So that means this whole thing goes to 1. So if I wrote 4x squared plus 2y plus 3 plus whatever to a 0 power, it's 1. Anything raised to a 0 power is 1, except 0. So it doesn't matter how much I have in the parentheses or what I have. If the 0 is the exponent, the answer is 1. I see a lot of confusion. Okay. Another way to explain it.
Because if it was raised to the first power, that would be the answer.
Sure.
If it's raised to the 0 power, you just have a value of 1.
Yeah, what if I had 2x plus 3 to the first power, which we usually don't write the 1, it's just that. It's just what's inside, right?
Maybe if, because I understand, but I think that if you do the X and make it like a number and then show that whatever number raised to 0 power equals 1, so you solve that in the parentheses and just raise it to 0.
So like say x to the
No, like, instead of having 2x, 2 times 2 plus 3 raised to 0 power, and then it's showing that, because if it's like 2 times 2 is 4 plus 3 is 7, so 7 raised to 0 power just makes it 1.
Okay. I'm not really understanding.
And that's what, I guess I'm just confusing.
It's okay.
I got it, but I just.
Okay, what would be 100 to the 0 power? 1. What would be 2 to the 0 power? 1. What would be xy to the 0 power? 1. What would be anything to the 0 power? 1.
I'm not confused about why it's, I'm not confused about what's going on.
Sure.
I'm confused about why it's 1.
Oh, sorry. Okay, that's a good question. I used to have this sheet that I would bring, because I inevitably have a student ask that. And I don't believe I brought it with me, but I can show you the proof. The mathematical people of the world that decide these things has a long proof to why it's 1. So you can either look at the proof, or you can just accept it.
I'll take the proof.
You want the proof? All right, I'll bring it. I actually look at my notebook, maybe I can find it.
I remember that.
Yeah, it's a whole page, and it's actually still argued in the mathematical community whether it's 0 or 1. But for the terms of this class and what's currently accepted,
It's 0.
it was 1.
Yeah. If it's not times by number, which is raised by itself, it should just be.
If you want to pass the test,
Right.
it's 1.
Yeah, but I will get that for you. It's kind of interesting if you like looking at that
It should
stuff.
be 0.
Well, no, because you're not times it by anything, just like it's raising it to the power. But there's no exponent, because there's no exponent, so it should just be 100. Because if it's 100 times 0, then it would be 0. But if it's like 100, no,
It should just be 100.
if there's nothing up there, why you're not doing
Why
it?
is it 1?
Okay, moving on.
That's the question.
You can also Google it and say, why is the 0 exponent 1? But I'll bring it for you. Okay, power rule is the next rule. The power rule says a value with an exponent raised to an exponent, you solve it by multiplying the two exponents. Bless you. So it's different from multiplying two base numbers with an exponent. This is one base with an exponent raised to another. They will be multiplied. Here's an example. Sometimes it's easier to see with actual numbers. Let's see if I have a different marker.
Do you have to write a dot when you write it? Can you just write NN?
I'm sorry?
Can I just write XNN?
Yeah, you can write X and N. I was just showing it was multiplied, but you can also write it like this.
I'm just gonna write
Sure. So here's an example of how that works. If I had z squared raised to the 4, it's z 2 times 4, or z to the 8. Okay, so a power to a power, you multiply the exponents. It's called the power rule. So what would this be?
X15.
X to the 15. Good. What would that be? 24. Very good. So the biggest problem with this is not to confuse the power rule with the product rule. So the product rule said this. It said m times x to the n is xm plus n. Whereas the power rule is saying xm to the n is xmn. Do you see the difference?
Yes.
Okay. To use numbers to show this, 2 cubed times 2 to the 5th is 2 to the 8th. However, 2 cubed raised to the 5th is 2 to the 15th. Very different numbers. So understand the difference between the two, because that's a common error, is to confuse those.
Will it always be in parentheses like that? Like X to the n?
Yes.
Okay.
If it's not parentheses, you're not raising it to a power.
Okay.
Okay. Now within the product rule, there's the power of a product. And it's just saying if you have more than one thing inside the parentheses raised to an exponent, you're applying the exponent to everything inside. So for example, if I had x squared y4 to the 10th, then it's x 20 y 40, because I'm using the same power rule of multiplying the exponents, but I'm applying them to each term. Kind of like the distributive problem, but using exponents. I'll do an example with real numbers with this one. This is a problem you might see in your book. Okay? And how we solve this is we're taking the 3 exponent to each term. So it'd be negative 2/3, the negative can go with the 2/3 cubed, times x 6 times 3 y cubed. So I applied the 3 to each thing. Now when it's a number, all I'm doing is cubing this number. When it's an exponent, I'm multiplying the exponents. So a constant works differently than a variable. What is negative 2 cubed?
Negative 2.
Negative 8. What is 3 cubed? 27. The reason it's not negative is I already accounted for the negative up here. Because this negative 2/3 cubed will be a negative 8/27. This is x to the 18th, y cubed.
In the
So-
homework, is it gonna want us to do actual math for constants?
Yes, always. can't leave it with exponents on the constant. So this would be the answer to that example. Okay, who would like to try this problem for
I
me?
actually have a question about that one.
Mhm.
Why would it be the -8/27?
Okay, what we're doing with that 2/3 is we're saying 2/3 times -2/3 times -2/3. That's essentially what the 3 means, right?
Yeah.
Because you're taking it 3 times. If I multiply the top, 2 times 2 times 2, because I have an odd number of negatives, I end up with negative.
Okay.
Do you agree?
Mhm.
And then 3 3s is 27.
Okay.
Make more sense?
Yes. Thank you.
And if you have to write it out at the beginning till you get this, that's okay. Okay, who would like to try this one? Keely.
It's at 1/16 times 4, x 4, and then y to the 9.
Got the 9.
6.
Good. And that's tricky because this
No,
square,
it was bad math.
but that's okay. I'm glad you said that because sometimes that happens. This square with a constant means you are saying 1/4 times 1/4. But with an exponent, you're just multiplying the exponents. You're not squaring the exponents.
So you're always multiplying the exponents.
Correct. Yep. So does this make sense to everyone? Okay. The next is the same idea, but it's the power of a quotient rule. So basically the quotient rule is what we did with division, and now we're raising it to a power. And it says x over y to the n is just xn over yn. And y cannot be 0. They just always write that in there to make sure you know that.
It almost sounded like you were shocked.
So here's our first example. So we're going to take this 3 to both terms, because this part is kind of like that, the multiplication. We're taking 4 cubed times a cubed divided by y cubed. So we're taking that 3 to every term in the problem. I have to do my 4 cubed, which is 64. The a cubed stays the same and the y cubed stays the same. Any questions on that example?
How would you use this in the real world?
Some jobs you might. Honestly, most of you won't, but the point of taking algebra is to teach you to think a certain way.
Well, I understand the critical thinking. I mean, I get that. If I understood that there was a practical application, it would help me.
There are practical applications to exponents. Like if we get into word problems and a and y represent 2 different parts of a word problem, and you had to solve it by cubing it, say you're doing volume, you have to know how to solve the problem.
Okay.
Yes. 64 is 4 times 4 times 4.
Oh, gotcha.
Yep. Good question. All right, here's one more example like this. -x squared over z cubed raised to the 5th. So how should I write the top, the numerator?
Negative x to the 10.
Negative x to the 10th over z to the 15th. Very good. The expanded power rule is putting this all together. It's where you could have a mixed bag of everything, okay? So if I have ax over by to the m, let's say, it's doing a little bit of your product rule, a little bit of your quotient rule, but ultimately what you're doing is taking this m exponent to every term in the problem. So how I would write that is a to the m, x to the m, over b to the m, y to the m. Does that make sense?
Do you always have to put that they can't equal 0, or?
Yes.
Okay.
That's kind of like,
Now, the example given in the book says b cannot equal 0 and y cannot equal 0, so could a or x equal
Yes,
0?
because they would be on the numerator,
Oh,
and that would make it 0. Why b or y can't be 0 is because it'd be undefined.
okay.
So basically, you can never have 0 in your denominator, is why they always put that.
but you can't have your exponent when it equals 1.
Those will always
Be in parentheses?
Okay, here's an example. 5x cubed y to the 5th over 4x cubed y squared. All of it is going to be squared.
Is there like an order of operations to follow?
Yes. What I was going to teach you next, after I show you this example, that's okay, is that you need to simplify within the parentheses before you take the exponent. But for this example, I'm going to change this. Okay, I'm going to change this. So what I want to teach you for right now, how to use this expanded power rule, is you're just taking every term and squaring it. When I say squaring it, the variables with the exponents, I'm not squaring, I'm multiplying, right?
So wait, in 4 times 4 is 16.
I'm not
No.
squaring it,
Oh,
I'm multiplying it,
that's true.
okay? You're only squaring your constants, you're multiplying your exponents. So this would be 4 squared down here, this would be 6, and this would be 4. Just look and make sure you understand how I went from one to the other. Okay, now I can clean it up because I can't leave my constants with squares. I have to write them out. 25, x to the 8th, y to the 10th, 16, x to the 6th, y to the 4th. But am I done?
No.
No, why not? I
You
can
can simplify.
subtract. Can I simplify the numbers, 25 and 16? Anything in common? Nothing in common. Those stay like they are. Let's look at the x's. Just take these one at a time. Remember I taught you to divide exponents, you do what to the exponents?
Subtract.
Subtract. So this is x squared. Because I'm taking x to the 8th divided by x to the 6th. So it's x 8 minus 6, which is x squared.
So does that take all of the x variables out of the denominator and leave it only in the denominator?
If you want to look at it like this, 4, 5, 6, 7, 8. I have 8 up here and I have 6 down here. Right?
Yeah.
I can cancel all but 2. That's why this works. Does that make sense visually?
Would you do an example where it's where the denominator is greater than the numerator?
Yes, that's when
Okay.
we get into negative exponents.
Okay.
But for right now, I just want you to see that when you're dividing these, you're doing 8 minus 6, so I have x squared.
Okay.
And Shannon, what would this one be?
Y to the 6th.
Yes, and it stays in the numerator because it's positive. Okay, so that is simplified. Does that make sense? We're gonna do
Oddly,
more.
yes, it does.
We're going to do more.
So positive numbers always stay in the numerator.
Yes. let's look at this one. What is the first thing I do? 2 cubed, which is 8. R what?
6
6. S what?
cubed,
3. T what?
12.
12. Okay, good. Now, simplify before you do the exponents. We're going to simplify within the parentheses before taking the exponent. Or I should say raising to the exponent. Okay, so how can I simplify within here first? 9 divided by 3 is 3. X cubed over x is x squared because I'm subtracting their exponents. There's an imaginary 1 here. If there's no exponent, it's assumed to be 1. 3 minus 1 is 2. How about the y's? They cancel, so do I have to write them? No. So now I've simplified it to this nice neat thing, cubed. Now I can take the exponent and I say 3 cubed x 6. I can't leave it looking like 3 cubed, so I have to write 27 x to the 6. So simplify what you can first, then use the product rule to take your exponent through each term. Because when you're taking an exponent to an exponent, you multiply. You are multiplying 3 to the 3rd next to the 6.
You
taking
got your
first.
steps confused. You have to multiply 2 times 3 first to get the 6.
Yes. This is 2 times 3. Okay, that makes sense?
Yeah.
Okay. Because when it's a constant, you're just raising it to an exponent. When it's a variable with an exponent, you're multiplying the exponent.
Yeah, I think that part. I mean, after the first week of time, it says
Yes.
and then I thought it was 6 times 3.
No. You understand now? I mean,
No, I
seriously,
do.
just don't-
I think you're trying to multiply the exponent and the constant together, and you can't do that. It has to be the constant and
Oh,
the exponent.
you're trying to do this? 3 times 3?
No. So we're doing the x, we're doing the x. It's just
Oh,
because
here,
you're separating
yeah.
out. So just like separating them out. They're gonna go back together like they're on the same page.
You can't multiply 3 and x together when they have an exponent.
Okay.
It's a different one.
Different terms. Okay. Let's do a few more, Zoe, and maybe it'll clear it up for you.
Yeah, sorry about that.
No, please ask. Sometimes I just am not sure what you're asking. Okay, so my first step is to simplify. What do I want to simplify my numbers to? 18 divided by 9. 2. Okay, how about my x? Here I have negative, right? Because I have 2 minus 5. When I have x2 divided by x to the 5th, I get x to the negative 3. Another way to write x to the negative 3 is to write it 1 over x cubed. Okay? Because this negative sign in an exponent means reciprocal. It doesn't mean it's a negative number. It's different than a negative sticking out here. That just means it's a negative number. When you have a negative exponent, this means to flip, reciprocate. Okay, so a negative exponent means to take the reciprocal. I'm going to do more of this in a minute. I'm just introducing it. So in this example, 2 minus 5, I get a negative 3. But if I put the x cubed down here, it's not written negative because it's on the denominator. If I wrote it in the numerator, it would be x negative 3. Here's why. X squared over x to the 5th. Think about it this way. There's 2 x's up here, there's 5 x's down here. When I cross them out, where are my x's left? On the bottom. So they stay on the bottom. So you don't have to worry about writing the negative exponent. You just keep the x's where there are more of them on that side of the equation, or of the fraction, I should say. So in this one, 8 minus 4, more of the y's are left on top, right? So it's y fourth on the top. All I want you to understand in this problem is when I have x times x up here and 5x's down here, I have 3 left on the bottom. Does that part make sense? Okay, cute. We're going to go over the negative exponents more in a minute. I just want you to understand why the x cubed is down here. Okay, now I'm cubing everything. So I have 2 cubed, y 4 times 3, x 3 times 3 when I write it out. So my answer is 8, because that's what 2 cubed is, y to the 12th, x to the 9th. Everybody understand? Okay, this is a common error when we're doing these kind of problems that students make some errors. This is correct because 4 divided by 2, we have 2 left. 2 times x. This is not correct. Why not?
That is in correlation to the unknown, right?
It's its own term. Down here it's being multiplied. Here it's being added. When there's an addition or subtraction sign, this is really 4 over x plus 4 over 2. They're separate terms. Whereas here, 2x is one term. So I can divide those. But here I have to break them apart. So the correct answer would be 4 over x plus 2. Okay, so if you have addition or subtraction on the bottom, you can't just go, okay, 4 divided by 2 is 2. That 4 belongs to the x as well. Okay, so it's 2 terms versus 1 term. Here's another example. X over xy becomes what? 1 over y, right? Because the x's cancel out. Boom. But if I said,
It was on the bottom.
because it's on the bottom. It's gotta stay where it is. But look at it if I put an addition sign here. Would it be 1 over 1 plus y? No, that's not right. Because when I put addition there, this x goes to both terms. Instead, it should be x over x plus x over y, which is 1 plus. Okay, so there's a difference if there's addition. Subtraction in the denominator versus multiplication. Okay, let's try this problem. We've learned all the rules of how to do things. Now we need to try some problems. This is going to be using the what rule?
I guess distributive.
The power rule is what it was called, because I'm raising something to a power on the outside. So I'm going to say 3 cubed x, 3 times 3 is 9, y, 2 times 3 is 6. Multiply my exponents. Over here, I just have x squared y. Nothing changes. So to clean that up, I need to write 3 cubed as 27, x 9, y 6, x squared y. Okay, I did my power rule, raising it to 3. So I think Melissa asked me about order of operations a minute ago. It's the same order of operations as we've learned before. You want to take care of in your parentheses first, your exponents second, then multiplication division. So now I have a multiplication problem, right? I'm multiplying this parentheses times this parentheses. So now I'm using the product rule, which means I'm adding the exponents. So the 27 stays there because there's no other number. The things that match the same bases are the x's. So I have the same base x, and I'm adding the exponents, the 11. And then I have the same base y. I add those exponents and get 7. So I have simplified that problem.
If you did have a number on the other side, you would multiply the numbers, right?
Yes. Like if there was a 2x squared y, you would do 27 times 2. Good question. Okay, so we raised it to a power first, got rid of our exponent, then we did the multiplication by combining the same bases. I'm going to do another problem on the board, and I want you guys to try this one on your own. Give that a shot. willing to try it? Scott?
Do you want just my answer? Or?
No, walk us through it.
Alright, so I did 2 to the 5th, which is 32.
Okay.
A to the 5th, which is 8 to the 25th. B to the 3rd, to the 5th is B to 15. And 3 squared.
Okay, is everybody okay so far? Okay, go ahead, Scott.
Then I did 32 times 3 is 96. And A to the 25th plus A to the 2nd is A to 27. And then B to the 15th plus B is B to 16.
Good. Okay, so that's the right answer. Everybody get lost in there. Okay.
32 and the 3, you
Yes.
don't add those together?
No, because the parentheses means we're multiplying.
Okay. And because
See,
those are constants, we can, okay.
This is the trick. People tend to apply the same rules of the exponents to the constants. The constants rules haven't changed from anything else you've ever learned. The only thing that's different that we're learning is when we deal with the exponents. So when you multiply exponents, you're adding. When you raise exponents to a power, you multiply. So be careful not to do it with your constants. Good. Okay, so that was 4.1. 4.2 is all about negative exponents. We kind of touched on it, but now this whole section deals with negative exponents. And all it's saying is what I told you a minute ago. If you have a negative exponent, another way to write it is to take the reciprocal. So x to the negative m is 1 over x to the m. This negative sign stands for reciprocal when it's in an exponent. The negative sign means something different in an exponent than it would as a number. It does not mean the number's negative. It means to flip it. And x, of course, cannot be 0. So if we had y to the 4th divided by y to the 7th, using the quotient rule, what do we get? Y to the negative 3. What is another way to write it?
1 over y to the 3rd.
1 over y cubed. Very good.
Are you going to answer the second one?
No. On a test, you don't want to leave anything as a negative exponent. That's a good question. So if you're working a problem and you get a negative exponent, your simplified final answer, you need to leave it as a positive exponent. Very good question. Okay, what's another way to write x to the negative 6? 1 over x to the 6. What's another way to write 4 to the negative 2? Good. 1 over 4 squared, which is 1 over 16.
If you had like 4x to the negative 6, would it be 1 over 4x 6?
No, it'd be 4 over x6. Is that what you said?
Yeah.
Oh, yes.
No. I said
you
4.
You wanted to put the 4 on the bottom.
Yeah, I wanted to put
4
4
does
on the
not go on the bottom.
Uh-huh.
Because remember when we learned before that exponents only go to what it's next to? The only way the 4 would go on the bottom is if this were in parentheses. Then the whole thing goes to the bottom.
Okay.
Does that make sense?
Mm-hmm.
So this exponent only applies to the x unless it's in parentheses, then it applies to all of it. That's a good question.
So would you multiply with 1 and 2, like forcing the negative 6 power and then put on the 1?
Yeah.
Yes, you would. I wrote that incorrectly. This would be 4 to the 6, right? Because using the product rule. So whatever 4 to the 6th is, I don't know that one in my head. It would be whatever 4 to the 6th is and x to the 6th, but they all go to the bottom. It's 96.
4,000.
Oh, 4,096. So it'd be 1 over 4,096.
Wow.
Thank you for pointing out. Exactly right. Okay. What would, bless you, 1/4 to the -2 of what? Bless you.
Just 16.
Just 16. Because now it's on the bottom, but it's still, this negative means to flip. It means reciprocal. So now I'm flipping the 1/4 and making it 4/1 squared, which is 16. So when I use this negative, I'm flipping it, and the negative disappears once you've used it. Does that make sense?
No, say that again.
Okay. To go from here to here, I removed this negative because I've used it. To use this negative exponent means that I flipped. When I flip it or take the inverse, the reciprocal, I've used that negative up, so it goes away.
Okay. I just needed to hear it again.
Yeah, it's okay. So what would y to the -8 be rewritten as?
1 over
1 over y to the 8. How about -4 to the -3? Remember, this negative means to flip it. So what's another way to write this? The negative out here stays, and another way to write it is 1 over 4 cubed. That's all I'm doing, I'm flipping the 4. So I get -1 over 64. Okay, this is no different than what you've been doing. I just threw a negative in there, and all of a sudden it frees us out. But the negative out here just stays. This negative makes the number flip.
Wait, isn't it 4 times 4, 2c, and then 2c times 3? Isn't it?
No, not times 3, it'd be 4 3 times. So 4 times 4
okay,
times
yeah.
4.
Okay. Never mind.
That's okay. Okay, how can I rewrite this?
So in exponents, the negatives don't cancel?
No.
Okay.
Because this negative means the -5. This negative means to take the reciprocal of it. They mean different things. But the difference between this problem and the one I did over there is, where's the negative this time? In the parentheses. So when I flip this, when I take the reciprocal, I'm going to take that -5 to the bottom.
It'd be 1 over -8.
Okay, so it'd be 1 over -5 cubed, which is 1 over -5 times -5 times -5, which is -125. What did you say, 80?
Yeah.
How did you do that?
5 times 5 is 25. 25 times 5.
Yeah, it's 125.
Yeah.
Okay.
I'm
You were
adding.
doing it correctly, you just
I'm just
misdid
tired
your
today.
multiplication. That's okay. As long as you have the process right. So do you understand the negative inside the parentheses versus when it was out? Yes.
Or I can negative on the answer 1 over -125. It doesn't have to be on the bottom.
No.
It just has to be.
It could look
It can
like
be on the top or in
this.
the middle, right?
Right. It could be off to the side or it can be up top. All of these things are the same.
But it shouldn't be on the bottom, right?
It could be on the bottom. Why I put it on the bottom is I was trying to show that when you cube a -5, you end up with a -125. You certainly can. This is the same as this, is the same as this.
Can you do that on MATLAB?
I don't know how it wants you to put it in. They probably want you to put it off to the side. Typically. Because usually if this whole number is negative, they like to see it out to the side. But mathematically, all these are the same. MATLAB's just
Very odd.
I just wrote it down here because I wanted you to see when you cube the 5, that's what it is. Okay, as opposed to this problem. Looks about the same, right? But what changes? It's not in parentheses, but will I end up with the same thing? Because this negative stays out here, and then I get 1 over 5 cubed, which is negative 1 over 125. Ends up being the same in this problem, but it won't always stay the same. Because if you had an even number exponent, it's going to make it positive. It just happened to be an odd exponent, so it stayed the same. Okay, how would I rewrite this?
I don't understand that one because I'm very new. Oh, I just did that.
The negatives in front of the 1 over 4. This guy kind of got squished over there.
Over 6.
Good. 1/6. That's all that is. Very good. What would this be? 1 over 2 cubed, which is 1 over 8. Okay. So the more you do of these, you'll get the hang of it. But the key is the negative in the exponent means reciprocal. It doesn't mean negative number. So if I reverse this, does anything change? What's another way to write that in a positive exponent? Just x to the 4. This time it's just on the bottom, but this negative exponent still means reciprocal. So another way to write this one is just x to the 4. It's just on the bottom this time, it's in the denominator. X to the negative 4. How about 1 over 3 to the negative 1? Just 3. Because what this negative does is flip this, brings it to the top, so it's 3 to the 1, which is just 3. Okay. Try some problem. Okay, we want to simplify this. Okay, remember I told you order of operations we do inside the parentheses first. So what's another way to write a to the negative 3? 1 over a cubed to the 6. Now I can take it to the 6th power. So it becomes 1 over a to the 18th because I multiply my exponents. Now another way to look at this is one way, would be to just multiply these exponents and get negative 18. But because you can't leave it in a negative exponent, you would rewrite it. You get the same result. Do you see the difference between the two? So you can either multiply the exponents or you can flip it with the negative and then take the exponent. Which one always works? Both always work. Okay. I'll just check. As you get further in math and you're doing lots of problems, this is the way you will do it. It's just quicker. You're not going to take the time to write a reciprocal and then take the exponent. So if you want to get used to doing this way, that's perfectly fine.
What if the 6 is negative?
If the 6 is negative, that's a good question. Let's rewrite this problem. Okay. One way is to flip it first, then take the negative exponent and flip the whole thing again, and then multiply. Or just say a to the 2. Because a negative and negative is a positive. So this kind of shows you what it's doing. Multiplying the exponents gets you a quicker answer. Okay. If I solve within the parentheses first, I get 8 to the negative 2 Then because it's negative, I am going to flip it, and then I square it. Okay? Too fast, I lose you. Or we could have said 2 to the negative 6. And realize 2 to the 6 is 64. We'll note 1 over 64. That's another way to do it. What happens when I multiply the same base with exponents? What do I do with them?
You combine them.
What am I doing with these two numbers? Adding is what I'm looking for. I knew what you meant, but I'm looking for the term. So because of the same base, I'm adding. So I'm doing 4 plus a negative 9, or y to the negative 5th. But I can't leave it as a negative, so my final answer would have to be put it on the bottom. Anybody want to try this problem?
So if they're both negative, I'm just going to add them together.
Yes.
So it's going to be 2 to the negative 5th power.
Good.
And I'm going to flip it to 1 and 2 to the 5th power.
Good. Which is?
25, 1 over 25. Oh, I'm sorry, 2 times 2 times 2 times 2 times 2. I don't know. 32.
Good. As long as you know it's not 25.
The mechanics.
Because it's not 5
Right.
squared, it's 2 to the 5th.
Right.
Good.
Right.
Very good. Okay. Okay, which one of these is right? First one or second one?
The one on top is 3.
This one you think's right? Who thinks this one's right?
I think the one on the top, the one that's equal to one that's not.
Okay, most of you do. It's not. That's why.
Hmm.
Why is that not right?
Because the egg change again.
Oh, it's an equal
Because you're not multiplying the term.
Because you're not multiplying. You can't add exponents when you're adding the bases. Adding the exponents only works when you're multiplying. So add exponents only when multiplying the bases. So this one is wrong. You cannot add those exponents. This would be the right way. That's actually what you come to. Good. I'm glad I did that one. Gonna write some problems on the board. I want you to try them. We'll go over them. Here we go. First problem. We are simplifying. This last one's getting kind of hard, so just try it. We haven't gone over it. If you can't do it, that's okay. don't get used to putting this in your calculator. Because I'm gonna have to think about in this next test, I may not, I don't know yet, but I may not allow calculators for the simple reason these graphing calculators, you can put in the number in next one.
We just use regular calculators, not graphing?
Possibly. I need to look at the test. I'm not making that call right now. I'm just saying don't do your homework and get used to plugging it in the calculator, okay? Any problems with the first three?
Just kind of
I don't think we've tried these yet. No. So if you can't do them, it's okay. We're gonna cover them. I'm just saying. I just want you guys to try some. See what's going. No, we have not. But they're using the same properties, the quotient rule. You're still subtracting your exponents. So I'm waiting. Raise your hand if you're not done with the top row. That's all I really, okay, I want to make sure. Not including the one over there, Shannon, this is the top three.
Oh, yeah,
You
I'm
know
done,
those.
yeah.
Okay, so, first problem, any volunteers? Keely.
I think it's z to the fifth.
Okay, well walk me through it. What did you do?
I just took, because there's z is 11, and I just took the exponent and then subtracted them, and then.
Okay, that's what I'm looking for. You subtracted the exponent. So you did -6 minus 11, which is what? This
Okay.
would be -17.
So it would be 1 over.
Z to the 17.
Okay, because I just thought there was positive 11. So.
Gotcha.
Okay.
Okay, does that make sense to everybody? We're just subtracting the exponents and then putting our final answer into a positive exponent. Okay, how about the next one? Would you like to try that one? calling somebody, thank you in the back, Renee.
Okay, so I got 1 over 5 squared, because negative 5 minus 5 is 2.
Minus a minus 5, good,
Is 2.
is 2.
And ultimately.
It's negative 2, right?
It's
1 over 25. So
That is
negative
way
7
easier than I got.
plus 5 is negative 2, and then you have to flip it and square it. So 1 over 25. Okay, next problem. Go ahead. Okay, so you did negative 4 minus 5 gives you x to the negative 9, and what's the way to rewrite it? To the next one. Very good. Okay, anybody having trouble with the top row here?
The second one,
Is the minus confusing you?
well, I added them. But I think I just saw why I did that.
Okay, it's because the exponent on the bottom is already negative, so when you subtract it, the negative becomes positive.
So maybe we did that. Okay.
You okay? Alright.
Oh.
Okay, this problem.
I did 3 minus negative 7, which is ended up being 10. And then it's just 1.
Very good, 5%. It's another negative. Which should do that. Very good. Okay, we're getting a little harder. Anybody willing to try this one? Well, those were easy. Were they? Okay. And so what do we do first here? Because we're multiplying, right? So we multiply the numbers, 3 and 4, we get 12. Then because the y's are the same base, I can add their exponents. So I get 3 plus a negative 4 is a negative 1. But I have to write my final answer without the negative exponent. So I get 12 over y.
Wait, why would you split them?
I didn't split them.
Why wouldn't you want
It was 12 times 1 over y, because this negative means you flip. And then I just multiplied and had the 12 on the top. Is that what you meant by splitting?
Yeah.
Did
To me, I thought it was 1 over 12.
Well, the 12 doesn't get flipped because it's not in parentheses. So the negative exponent only affects the y. If it were in parentheses, the 12 would move as well. That's a great question. Okay. Moving on to this problem. We need to simplify. So first we simplify the constants. What do I get for that? 4. Then my a's, I say negative 2 minus 1 gives me negative 3.
So would you just go ahead and put the A on the bottom?
You could if you think that way, that's fine. I'm doing it in steps just so people can follow.
Okay.
But if you know that goes to the bottom, you can go ahead and write it there.
Okay.
Then 4 minus 2 would be 2. And what Keely's saying is she wants to move this to the bottom because it's negative. So it's going to end up being a cubed on the bottom because it is the reciprocal. And if you can go ahead and write it that way, that's perfectly fine. I'm just trying to be consistent, showing you the subtraction of the exponents and then flipping it at the end. Okay, last one. We're going to simplify the constants. So we get 2, and then we get r what? Squared. And s what? Negative 5. So I have to rewrite that as 2r squared on the top and then s to the 5th on the bottom. Excellent. Okay, same kind of problem. We're going to simplify our constants first. And what do we get? 1/4. So 2 divided by 8 is a 4. So 1/4. You don't have to write the 1, I just did that so you can see what it is. The x's, what am I going to end up with? Negative 5. Now here's where you have your choice. You can write x fourth, 1/4, and then x negative 5, or you could have gone ahead and wrote x to the 5th on the bottom. If we do it this way, then 5 minus a minus 3 becomes y to the 8th. Then when I clean it up, the only thing that stays in the numerator is y to the 8th, and the 4 and the x to the 5th are in the denominator. Okay? Okay, Melissa?
What's 5 minus 3?
5 minus a minus 3. Because you're taking 5 minus a minus 3.
Oh.
Yeah. I could tell by your face you were looking at something. So. Does that help? Okay. It's like this one, or like this one. What's that? When you have the negative on the bottom.
But the 5 on the top is not negative. So it's
Right.
not like you're doing this.
But if you're doing just this, it's 5 minus a minus 3, which becomes 8. Okay? Okay, using the product rule, no, sorry, the power rule, we're going to take this negative 2 through both terms. So I get 4 to the negative 2 and y to the 10. I have to rewrite my negative exponents, so this becomes 1 over 4 squared, y to the 10th, y to the 10th over 16. Same kind of problem. I'm going to distribute this negative 2 to each term. I get 5 to the negative 2, x to the what? 6. When I clean that up, x to the 6 stays in the numerator. 5 squared goes to the denominator because of the negative.
Like the last one you said, did you keep it as negative 16?
Sure. Another way would be 1/16 y. That's the same thing. Okay. Same kind of problem, but I'm sticking the negative in here. Let's see what changes. So now when I write 5 to the negative 2, I have to take the negative 5 with me. So when I flip this, it's 1 over negative 5 squared. 1 over 25 x6, so I get the same result. And that's because it was an even exponent, the negative went away. Okay, 1.5 pages left. Everyone good? So in that last one with the negative, it stayed the same because I said we had an even exponent. Let's see what happens if I have an odd exponent. So same problem, but this time instead of negative 2, I'm going to do a negative 3. So it's going to be negative 5 to the negative 3, x to the negative 3 to the negative 3. I'm taking the negative 3 through both terms. What happens with negative 5 to the negative 3? It's another way to write it. Good. And then how can I rewrite my x? To the 9th, because negative 3 times negative 3 is a positive 9. Down here I need to clean it up. 5 times 5 times 5 is 125. But is it positive or negative?
Negative.
It's negative. So the answer is negative this time because of the odd exponent. Okay, which one's right, which one's wrong?
The first one.
The first one's right, this one is wrong. Okay, why?
Because,
Because of what, Scott?
they're adding the terms.
They're adding the terms instead of multiplying the terms. Same thing again. When I add or subtract terms, this W belongs to both. So it has to be x cubed W plus y negative 2W. Then you can move your negative. Okay? So that addition subtraction sign means when you are trying to break something up that the W belongs to both terms as opposed to when you're multiplying. Very common errors, that's why I keep bringing them up. Make sure you don't do that. Okay. Okay, this time I have no variables, I just have constants. How else can I start writing this? 4 negative 2, 3 negative 2. Then what? Flip both of them. If I flip the 4, it goes to the bottom, or the denominator, and I get 16. If I flip this one and square the 3, I have a 9 that goes in the numerator. 9/16, okay? Let me show you another way to do this. If I had used this negative exponent at the beginning, I can immediately flip the inside and just square it. It's doing the same thing. So whether you flip and get rid of this negative first, or you distribute it and then flip, is up to you, okay? So as long as you use a negative exponent to take the reciprocal, it doesn't matter if you do it first or after you distribute. Let's try another.
So in that case, would you leave it or, oh, I was thinking you could reduce, I'm sorry.
Oh, yeah, if you
brain
can
fart.
simplify, you would, but in this case you can't.
Okay.
So the generic way to write this is if you have a over b to the negative m, it's the same thing as b over a to the m. Because like I told you before, once you use this negative exponent, it goes away. And you use it by taking the reciprocal. So if I had 5/6 to the negative 2, how could I rewrite that? 6/5 squared, which would become 36/25. If I had a cubed b to the 6th to the negative 4, what would I want to do first? Flip it. And then raise it to the 4th. So I get b24, a12. It just keeps you from having to move your negatives after the fact. Thank you. Because then I had 2 to deal with, versus if I flip it at the beginning, I can immediately go to my answer. Okay. you think this method would work for a more complicated problem?
Yes.
Sure. So I could immediately flip the problem in the parentheses and just make it to the 6th. So I've used up that negative exponent. Now I can take each term to the 6th power and I get negative 18, 18, and negative 12. Can I leave it like that? No. So I have to rewrite it. Do I move the z?
Yes.
Yes. To where? The bottom. Do I move the y? Yes. And I wrote that you don't move the x because there was no negative. So that is one way to solve the problem, is to flip it first, then take it to the 6th power. What is another way I could have done it, the way we were doing it? Just started from here and distributed the negative 6. So another way I could have done it is just said x to the negative 18, y to the 12, z to the 18, and then moved what I need to move. In this problem, it's really 6 of one, half dozen of the other. I mean, you get to the same answer, it's just 2 different ways to approach it. I just want to show you that it really works. All right, guys. We're getting there. We have one more. That's it. You might get to go early today. We'll see. You guys seem extra tired today. Sorry. Okay. So distribute. There's no negative here, so I'm not going to flip anything first. So I'm just going to distribute. 2 cubed. I'm going to go ahead and write the 8. X to the negative 6, y to the what? Z to the what? X to the 15. Okay, anything I need to move? X to the 6, so what does it become?
X to the 21.
21. So what I'm saying is negative 6 minus 15 is a negative 21, which means it comes on the bottom. So, 8, y, 9, z to the 6, x to the 21. All right, so that's it for the lecture, but don't run off yet. I want to hand you something. And you can come see your grades. So the homework is open to start working on, and then I have a worksheet for you to practice. So we can either stay here for another 20 minutes of class and work on the worksheet, or you can take it with you and do it at home. Which one?
Take it home.
I thought so. Yeah, or take it to the math lab and get some extra help. That'd be great too. And anything to the 0 power is 1. So come up and see me if you want to know your grade. And I will see you guys on Thursday. Oh,